This is a quick demo of our new MAGFit web tool. So firstly, what is a MAGFit? So a MAGFit is a calibration for your compass based on a flight log. So rather than standing on the ground doing the compass dance, you go and fly the vehicle round and calibrate the compass that way. And it has the advantage that firstly, you don't have to dance around with potentially a heavy vehicle. And because it is in flight, it's away from any interference source that might be on the ground, and anything, for example, motor current, can be compensated for if it's causing an issue. So MAGFit is generally a great way to either calibrate your compass, and you can also just use it as a double checker to make sure that your compass calibration that you've got already is okay. So this is some instructions on our wiki. So refining calibration parameters using a flight log. So this is just a new tool to do what you can already do with Mav Explorer. There's a little demo of how to do it with Mav Explorer. These hints and tips also apply for both methods. So one of the key things you want to make sure if you're going to do a MAGFit is to make sure you've got a good flight for it. So you want to be moving around and have a nice range of yaws. And if you're trying to fit throttle or current for a motor calibration, then you want to have a nice range of either throttles or battery current in the log as well. And generally, the longer the flight is, the better, and the more orientations you can hit in that flight, the better. So roll and pitch as well as yaw and combinations of everything. So first of all, we're going to go to the firmware page, firmware.ardupilot.org, and then we scroll down to the bottom, and there's Web Tools. So this is the new Web Tools landing page. There's of course the UAV log viewer. There's the hardware report, filter review we've talked about before. There's the filter tool, which is the one we've had for a long time. There's also PID, which is still a little bit experimental. And today we're going to have a look at MAGFit here. So I'm just going to click that. And then it asks you for your log. So we'll just pick a log. Let's try this one. So this is a little flight. You can see there's some flight data. So if you're familiar with the filter review tool, this is just to give you a little idea of where you are in the flight. So probably we would straight away crop out this bit at the beginning and the bit at the end. So there's no point in including the bit before we've taken off. And there's no point in including the bit after we've landed. So we'll just zoom in. You can also twiddle the numbers in the start and end box up here. And once we've done that, we're just going to hit calculate. So that's start and end. You can change attitude source if you want to. By default, it will use whichever attitude source is set up on the vehicle. So here we're using EK3, IMU2. But if, for example, you had a flight where the compass was very bad and therefore the EKF was upset, you could potentially pick a different attitude source because you know the one that was selected gave bad results in the flight. So this is a little overview of what compasses are. So it's found a drone can compass, a second drone can compass, and then this EK09916 on SPI. So it tells you if we're using the compass, you get a tick if it's used, you get a tick if it's external, and you get a tick if it's healthy. So healthy in this case means, can ArduPilot talk to the sensor? Healthy does not mean that the sensor is giving sensible numbers, it just means the sensor is there. So you can see we've got an external compass that we're using, second external compass that we're using, and then an internal compass that we're not using but is healthy. And you'll see there's lots of ticky boxes and some plots. So first of all, the plots. So we've got the field strength in X, in Y, and in Z. So this is the measured body frame magnetic field. And there's quite a lot going on here, so I think I'll just turn off some plots. Let's turn off these ones, much like the filter review tool, there's ticky boxes that you can go and tick. So this is now just for the first compass. So you can see in black we've got an expected magnetic field, so it takes the vehicle's attitude and the vehicle's location and looks up the expected magnetic field in the world magnetic model. So that gives us this black expected line, and then the existing calibration here is in orange, so that's what the vehicle is flying on. And then we've done a calibration here just using offsets, and that's in green. So by this fit, we've gone from the orange up to the green here. And you can see that's the same in X and Y and Z in all three axes. The green fits a little bit better than the orange. You see nicely on the line here. They're all both a bit high to begin with, and then Z again, we're fitting reasonably well there. So you can see the existing calibration, what we've come from, and then what we would get if we leave this offsets selected. Then there's a change in yaw. So this is if we were to go from the old calibration to the new calibration, what heading change would there be? And in this case, we're getting quite a big change, which suggests that the existing compass was perhaps having a bit of a bad time. So you can see 30 degrees change about through the whole flight. It is reasonably consistent, at least. So perhaps something that is fixed with this x-axis here going up there, that's probably caused that change in heading. And then this second heading change is the change between the original calibration and the new calibration compared to what the EKF thought the heading was. So the EKF is very good at compensating for these calibration deficiencies in flight. And you can see once the EKF has done a little bit of flying, it's probably worked it out, and you can see actually our new calibration is giving very close to the expected result. So if the new calibration was saying, oh, your yaw was 90 degrees wrong, but the vehicle flew okay, that's extremely unlikely to be bad, to be a valid result. So it would be a bad calibration. So that's that, and then it plots the expected field length, so the sum of the x, y, and z axes is in black here, which of course doesn't matter what orientation you're at, the total length of the vector is the same. And again, you can see the new calibrations moved us up a little bit closer to that expected length. And then this is one of the available motor compensation sources. So in this case, it's battery current. And if we saw a big spike in this plot, perhaps here, where there's a spike in this length, we might go, oh, it would be worth switching on current calibration there. But in this plot, I can't really see there's any correlation between the error here and this source of interference. So it's probably not worth doing a battery current compensation on this particular log. There's a fit error, so this is just how well it was able to fit throughout the duration of the log. You can see it was a bit worse at the beginning of the log, and then it's got quite a low error for the rest of the log. And then this sort of bar graph is just the area under this curve. So the existing calibration is a big number, and then the offset no motor compensation, which is the calibration we're looking at here, it's got a lower number, 31 is the error for that. And it also does a number of other calibrations. So if we go back to the top here, you can see all the other options in here. So we've done, in fact, 6 calibrations here, and you can pick which one you would like to use. And if I we see there's very little difference between all of these, which is a good sign if you can fit with the minimum possible number of parameters. So you can see, and that's reflected in these errors. So it really, there's not any massive improvement here in fit by including extra parameters. So what we would probably do for this log is just leave it with just the offsets calibrated. So that is that. If we go and look at perhaps this internal compass, first of all, you'll see I actually can't select some of these more complicated or fits with a higher number of parameters. And that's because it did the fit, but the parameters values it got were nonsense. So it said, I tried to calibrate it, but I can't. So you actually can't select those ones. So we just get the offsets here. So that's just bringing the individual axes in line. The more complicated or the increased parameter fits adds a scale factor, so just scales all the vectors, and then the offsets and iron does the hard and soft iron compensation matrix. So on this compass, I thought we might see a little bit more correlation between the error and the battery current here, right? And I think maybe if we sort of zoom in here, you can see all spikes here up and down. So on this internal compass, and certainly at the beginning and end, it's really clear. You can see it spikes up, follows it follows current quite closely, and then drops down again. So it's extremely clear on this internal compass that there's a very strong interference from the battery current here. So we can select a fit with battery current compensation. And you can see that's done a little bit better. So we've gone from big error at the beginning of the flight to sort of a bit less error in the middle, but it's still really not really an acceptable compass to use. You can see we got about 30 on the external compass as the error for the whole flight, and here we're getting 150. So even with the current compensation, still not a good idea to use this third compass. So whoever set this up was correct in not using that compass. So we would continue using these first two, I think, in this particular log. So I've selected offsets here. We haven't actually selected this third compass at all. So because these are the last two I had ticked in this box, if we now go right to the bottom, you'll see it's populated those calibrations in the little sort of parameter display here. So you can't change these numbers. These are just from the calibrations. And it says here what it is that it's displaying. So this is the offset calibration. There's no motor compensation, which is the same for compass 1 and 2. And then it's actually the existing calibration. We haven't got anything selected for the third compass. So if I hit save parameters, it's telling you what it saved. It saved compass 1 offsets, no motor compensation, compass 2 offsets, no motor compensation. I hit OK. It's downloaded a file, and that's our parameters. So it's got the offsets, the diagonals are 1, the off diagonals are all 0, no motor compensation, scale of 1, compass orientations there. And you can see the same for the second compass, and we've turned off the sort of global motor compensation parameter. So you could then just go and take these params and load them onto your flight controller, and that would be your compass calibrated from this MAGFit. So that's a sort of basic overview. I think the key thing is to not, you don't want to sort of rush into the really complicated motor compensation and scale and iron correction if there's no real benefit. So let's have a look at another log, and we'll have a look at some more of these options here. So let's clear that, and then let's have a look at this long flight here. So it's a bit of a longer log, so it's going to take a little while to load. So you'll notice it says MAG1 possible incorrect orientation, 0 none, should be should be 12, pitch 180. And it says it's got a cost ratio of 4.8. So that means that this pitch 180 rotation is 4.8 times better than the next orientation. So we're just going to say, okay, and it will carry on. So in this particular log, there was a lot of, I think it had disarmed logging turned on. So there's a big long chunk at the beginning of the log. So we'll just zoom into the end here, and I'm just going to recalculate. And again, it's warned us the same warning. But now we've excluded that beginning of the log. You'll see this cost has gone up to 40 times. So it's really very sure that this pitch 180 orientation is correct. And we can go and look. I'll just turn off the second and third compass here. Just so there's a bit less going on, and we'll turn off the calibration. So it's very clear here that the lines are not even close to matching. They're actually going completely the wrong way. In the x-axis, y looks okay, and then the z-axis is wrong. So it's very clear something's wacky here. So what we can do is this little parameter changes box. So under orientation at the moment is selected check, which is what is selected by default, which means it warns us. And it said pitch 180. So if we select fix 90, which means it will fix to the closest 90-degree orientation. So obviously you've fitted your compass to the vehicle, and you know if it's a multiple of 90, or if it isn't a multiple of 90, you can let it fix to one of the 45-degree rotations. But in this case, we know it was 90 degrees, so we're going to hit fix 90. It's going to run again. And now you'll see, of course, the existing calibration is the same. It's still got the wrong orientation. But if I just turn that off, you can now see, and we'll turn off the other two compasses as well. You can now see by fixing that orientation, it's been able to nicely line up the X, Y, and Z. So it can fix orientations for you. So although having said that, if you are flying the vehicle, this was quite a dodgy flight because it had the incorrect orientation. So if you're not sure, what you can do is fit the compass, but you don't select use. So it won't use the compass which you're not sure of the orientation. And of course, you don't actually have to fly for this this MAGFit, although the built-in compass stands will also correct orientations for you. So if you're not going to fly, you could just do an on-the-ground compass stance. So in this particular case, you can see it's fixed the orientation. It's got a much better calibration. Now, there's an extremely big change in yaw, and that's not because the new calibration is rubbish. That's because the old calibration was rubbish. So that's why we get this massive change in yaw here, and we know that the compass had the wrong orientation. So we go, oh, that's okay. And you can see that because of that, the existing calibration in orange here also greatly disagreed with what the EKF thought it should be. And our new calibration is much better, within maybe 10 degrees. So again, that's another confirmation that, I guess, the calibration is correct. And again, the field length was just all over the place. In this particular log, there was no current monitoring, so there's no compensation source. So we can't look at that sort of correlation there. And again, this is fit error, and we know that compass was completely wrong. And again, this is a log where we get about the same, even if we include the sort of more complex dimensions in the fit. So probably here we would just set offsets. There's no significant improvement by including the extra parameters there. And I will also add that like the length of the log shouldn't matter for these comparisons. So if we sort of, or rather if we go to the top and zoom into a little bit, the error score should still be equivalent. Let's see, so it's a bit lower now. I mean, it's a bit hard to say. So it should still be comparable between flights, roughly, because it is normalized by the length of the sample. So that's that. Let's just go back to the beginning of the flight. If we hit calculate here, you'll notice this coverage bar. So we get a very low score in coverage. So this coverage is trying to give you an indication of how good a flight it was for a MAGFit. So how many of the possible orientations did the flight hit? So if we're just looking at the beginning of the flight where there's no movement, you'll see it gets a very low score. And we get obviously the same score on all compasses in this case. But if we include a bit of the flight where there's actually some flying and we hit calculate again, you'll see that coverage score has gone up. And if we include the rest, we should see it gets a bit bigger again. So this is quite a good coverage. Now it is all possible orientations, and so that includes upside down and things like that. So you're probably on a flight not actually going to get more than maybe 40%. This is actually one of the reasons why the compass stance on the ground usually works really well, is because you have to get 100%. It will not complete until you've done lots of orientations, including upside down. But in this case, from an actual flight, we're not expecting the upside down orientations unless you're a very ambitious flight or you're flying an acro or something. So we get 40%. But if you're struggling to get good results, or you've done a MAGFit and it was no better, it might just be because you had quite bad coverage if you didn't sort of fly at enough orientations. And of course, you don't have to. There's no time limit. You don't have to fly all the orientations within 2 minutes or something. You can MAGFit on a big long log if you want. This one's 10 minutes or something. So there's no reason that you have to do it all quickly. It will just take a bit longer to run if it's a longer log. And of course, you don't have to do a dedicated flight if you're if you're having compass issues. You can run it through this tool. You probably wouldn't use the calibration parameters unless you'd done a dedicated flight, but it can also be used to sort of evaluate how the compass was doing. So let's see. So we've covered the orientation fix, check fix 45, and it will warn you with that little pop-up before it does an orientation change. So there's also this use selection here. So if we had a log and it was using a compass and we come to do the fit and go, oh, that compass really is terrible, you can actually override it to don't use. And often it's quite nice to have to calibrate the compass that you're not using, but still don't use it, because then you can still use it as a point of comparison, even if you know it's not a good idea to fly on that compass. And likewise, if you had a compass that was previously set to not use, for example, one you didn't know the orientation of, and you'd set it not use, you could then say, oh, I want to use it now. I've fixed the orientation. I've looked at the calibration. It's good. We can now start using that. And of course, by default, it says no change, which just means the use parameter will not be in the saved param set. So let's again go to the bottom and have a look at what this param set looks like. Again, it's telling us what the calibrations were. And I don't think I haven't got any selected, so it's not letting me save. Whoops. Let's turn off that. Is that going to let me save? No. Still a little bit of a work in progress, this tool, I'm afraid. We didn't hit calculate, that's why. So because I had changed the time window here, you see I need to come up and hit recalculate. So let's go back to that. And that's set to use, and then we'll be able to save now, save params. So it warns you again that it's changed that orientation. And then it tells you again what it's saved. So we've saved our 3 calibrations for our 3 compasses, no motor compensation, and again, it's downloaded a parameter file. And now you'll find, because we had selected, yes, we want to use that first compass, it's got the compass use parameter in here for the first one, but you'll see there's no compass use parameter in here for the other 2 compasses. So that's that. Let's have another look. This is another one with a incorrect orientation, I think. Again, 40%, 40 times, so it's quite sure about the orientation. Ooh, the axes get a bit confused sometimes. In this case, it's a vehicle with just 2 compasses. We've got 1 external, 1 internal, and again, you can quite clearly see that first compass is incorrect orientation. It's going the wrong way, so we'll go fix 90, and now you can see it's been able to fix that for us. So yeah, that's MAGFit. Hopefully you get just as good results as you can currently get with the Map Explorer tool, but it should be a little bit easier to run. And it also, because it can do all these calibrations in one go, you can easily compare the different calibrations by if you want to include those extra parameters or not, and especially for the current compensation. Unfortunately, I don't have any example logs where they really need a lot of current compensation. So yeah, that's the new MAGFit tool. Again, it's only been live for a few days, so there could still be a few issues to work out as ever. If you do find a bug, there's the little GitHub button up here. Hit the GitHub button, navigate over to issues, and create an issue, and tell us what went wrong, and upload the log. And of course, we've got the new WebTools landing page, so go and have a play with some of the other web tools. Thank you.